Hello Algebra 1. Today we are going to be reviewing the concepts that we've been working on the last few days. So here we go. First thing we're going to do is match the representation to the type of relationship, and of course answers may be used more than once. We have linear, exponential, and neither. So number one, this will be an exponential relationship because we can see that our x is our exponent. So again, exponent for exponential. And number two will of course be a linear relationship because this is in the form y equals mx plus b. It just happens to be reversed in this case. Number three, the number of students doubles each year. Doubles means multiplies by 2, and multiplication is exponential. Sarah makes $18 an hour at her job. That's a constant rate. Okay, so her amount of money she's earning, it's increasing $18 and then another $18 and then another $18. That's addition. That means this is linear. Justin's investment appreciates by 15% each year. Appreciates means it's increasing and we have a percent here. That would be exponential. Specifically, it would be exponential growth. Okay, number 6. It's hard to tell what we're multiplying by here. It's certainly not adding by a constant number, but if we go ahead and we divide, 45 divided by 18, it's multiplying by 2.5. So let's try that now. 45 times 2.5 does give you the 112.5. If we times by 2.5 again, you get that 281.25. So these are multiplying by a constant number, which also makes this exponential. And then here we have 0, 1, 4, 9. These are not going up by the same amount. And they're also not multiplying by a constant number either. So that means this is neither. All right, so let's review our exponential growth and decay equations. For growth, you should have a y equals a, and then in parentheses, 1 plus r to the t power. And exponential decay is going to be the exact same thing, but you're going to have a minus. All right, so we're going to determine if we have growth or decay and determine the rate. 9 is going to be growth because my number in parentheses is more than 1, and 10 is going to be decay because my number in parentheses is less than 1. So for growth, to figure out r, I'm going to set this number equal to 1 plus r, okay, because growth is plus, and decay, I'm going to set this number equal to 1 minus r, because decay we subtract. So to solve for r, I just subtract 1 on each side, and I'll get 0.23. We do want to write it as 23% though. Okay, and then actually for decay, you're doing the same thing. Subtract the 1 on each side. This one's just a little harder to do in your head. 0.67 minus 1 is negative 0.33. But again, don't be alarmed by the fact that it's negative. You still have to divide by your negative 1. And you should get r as 0.33, which is 33%. All right, this one we're going to change a little bit just to make the numbers a little nicer. We're going to go with 9%, so you can change that in your packet. When you were born, your parents deposited $2,000 in an account, paying 9% interest each year. So this means we're earning money, which means we have growth, which means we're going to have a plus. So I'm going to put a y equals. My starting amount is $2,000. I have 1 plus 9% is, make sure you divide by 100, 0.09. And then don't forget your to the t power. If you want to go ahead and combine those, you can. 1.09 to the t power. Okay, how much money will be in the account when you turn 18? So again, identify that number. Is that a time that has passed, or is that some other value? And 18 is talking about 18 years, so that is t. So we're going to plug that in right there. So y equals 2,000, 1.09 to the 18 power. I'm going to use my calculator to do this. Make sure you use raised to the 9434.24. 9434 point, what did I just say? 24. Okay, there you go. How long will it take for the money in your account to double? Okay, well, think about it. You started with $2,000. It's doubled, so now it's going to be $4,000. So what are we going to do with that 4,000? Is that a time or is that some other quantity? Well, it's money, right? So that means it needs to go in place of our y. Don't worry about what we just did in part B. Go back to the original equation, this guy right here. We're just plugging 4,000 in place of y. Okay, and then I'm going to type it in. We're going to go to y equals, clear out everything you have. Y1 is going to be 4,000. That's anything before the equal sign. Y2 is going to be 2,000. 1.09 to the x power. Okay, we will have to change our window. We want our y max to be something a little bigger than the biggest number in our problem. So the biggest number in our problem here is 4,000. So I'm going to go with like a 5,000. And graph. Okay, and then I can go second trace 5, enter, enter, enter. And this is going to be 8.04. Draw my line. Okay, so this was 8.04 comma 4,000. So again, you're looking for t. That's your x value. We're going to write t equals 8.04 years. Okay. How long will it take for there to be $2,500 in the account? Well, again, $2,500 is just an amount of money. It's going to replace y. So it's really the same thing as letter C, except instead of a 4,000, you're putting a 2,500. Okay, and this is another graphing one. Go back to your y equals, just replace that 4,000 with 2,500, and you can go ahead and press graph. And you should get a very similar picture. And in order to find that intersection point, again, we say second trace 5, enter, 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 which is 2.59, comma 2,500. And again, what we care about is our t value, 2.59 years. All right, let's try one more. Mark decides to invest $4,000 into the stock market. Unfortunately for him, the stock market depreciates 5% each year that he has the money invested. Again, depreciates means going down. So when we write our model, we need to have a subtraction symbol in here. Okay, so 4,000 is my starting amount. I have 1 minus, and then my rate is 5%. So I'm going to do 5 divided by 100. Which is 0.05. Don't forget your to the t power. Now we can go ahead and we can subtract those, which is 0.95. So either way is fine. All right, so question B, how much money will Mark have left after 5 years? Well, 5 years, again, identify, is that time or is that something else? And 5 years is a time. So we're going to plug 5 in for t. So 0.95 to the 5th power. And this is something we can just type straight into our calculator. And this is $3,095.12. And finally, how long will it take for Mark to have half of his money left? Well, he had $4,000, right? If he has half of it left, how much is that? 2,000. And is that 2,000 years or $2,000? It is money, which means it's not going in place of t, it's going to go in place of y. And again, don't worry about what we did in part B. Always go back to your original equation. We're just going to plug 2,000 in right there. So the 4,000 and the 0.95 to the t stay exactly the same. However, this is one we will have to graph. So go to your y equals, clear it all out. Y1 is 2,000. Y2 is 4,000. 0.95 to the x. And again, we're going to go ahead and graph. And you should see that we do have an intersection point here. Second trace 5, enter, enter, enter. And your t value is always your x value. So this would be t equals 13.51 years. And there you go. I hope this helped. Have a great day.